In addition to production variation, insertion depth, and ear tip type, another significant cause of variability in frequency response is the interplay of the source's output impedance and the headphone's impedance curve, which describes how the headphone's impedance varies with frequency. Even with an apparently small output impedance of just a few ohms, the frequency response of certain in-ear monitors can be significantly and very audibly altered. When connected together, your source device and headphones form a voltage divider such that the greater the output impedance, the greater the voltage drop across a lower impedance headphone load. Since many modern headphones have impedances that vary with frequency, the voltage delivered to the headphones will also change with frequency, and the larger the output impedance, the larger this frequency response variation. A general rule of 8 suggests that these variations should be minimal if the output impedance is at least 8 times smaller than the headphone impedance. So, for example, a 1 ohm output impedance should be safe driving a device like the 8 ohm Campfire Audio Andromeda. But in practice, a rating of 8 ohms only means 8 ohms at 1 kHz, and remember that impedance can vary with frequency. In the case of the Andromeda, it is roughly 8 ohm at 1 kHz, but its impedance drops to less than 4 ohm in the lower frequencies. The resulting effect can be calculated by entering the source's output impedance, or Zout, in the expanded tool menu in SPL mode. By default, the tool assumes a 0 ohm output impedance, but if you know your player's output impedance, you can enter it here and directly see the effect of it on the various headphones.